Prior to undertaking a thin polymer overlay project, read through the preview section of the Thin Polymer Overlay Project Guide. Review the list of items contained in this section to make sure that you are starting your project off on the right foot. This list includes many items that are often overlooked, but are considered important aspects of a successful thin polymer overlay project. For this project, a temporary signal is being used to maintain traffic. It is important to ensure that the staging of materials and equipment is executed in such a way as to maximize efficiency in production while not interfering with traffic. The next section of the Pocket Guide takes a look at surface preparation, one of the most critical components of your project. It is important that the shot blasting equipment moves very slowly across the deck to ensure the effective removal of contaminants and to open the pore structure of the concrete. The size of the shot media is also an important consideration. Make sure all the contaminants are removed and the blasting operation meets the requirements of the specification and/or the manufacturer of the resin binder. In this part of the video, contracting personnel are pushing a magnet across the deck to remove excess shot that was not picked up from the blasting equipment. Make sure that the shot blasting equipment is always emptied before it gets full and begins to leak cement dust onto the bridge deck. You will also want to make sure that the blasting equipment is emptied away from the application site and does not get blown back onto the deck. Dust from the shot blasting operation can inhibit the penetration and bond of the overlay system to the deck. For some projects, it may be required to remove the deck surface to a greater depth. Here, the contractor has elected to use a scarifier. A scarifier is often used to remove striping and/or rumble strips in preparation for a thin polymer overlay. A scarifier, sometimes called a milling machine, uses the pummeling action of multi-tipped cutting wheels, or flails, that rotate at high speeds to chip away at the concrete surface. In this part of the video, the contractor is using a diamond grinding wheel to remove some surface contamination from the concrete. Grease, oil, and other contaminants can penetrate into the deck surface and act as a bond breaker for the thin polymer overlay. It is considered good practice to remove these contaminants prior to your application. Since the shot blasting equipment typically cannot reach the edges of the concrete deck, the contractor has elected to sandblast along the barriers. Compared to shot blasting, sandblasting is a more labor-intensive method to remove contaminants, requiring careful attention. Be sure to comply with the safety requirements related to the blasting grit. Some blasting grit materials require the use of a standard issue air breathing apparatus. After shot blasting and prior to the thin polymer overlay application, you will need to air blast the surface with clean, oil-free compressed air. This is typically done with an air compressor, fitted with an oil trap, usually with a capacity greater than 175 cubic feet per minute and an attached air lance. Maintaining a distance of 12 inches or less from the deck surface, the air lance is moved using a circular motion to remove all the dust and debris from the pore structure of the concrete. As the resin binder begins to be pumped onto the deck, the role of each worker comes into focus. The two workers with serrated squeegees and spiked shoes are responsible for spreading the resin binder onto the deck at the proper specified coverage rate. It is critical to replace the squeegee blades as soon as the serrations begin to show wear. Keep extra squeegees on hand so that they can be easily accessed during the application. When the squeegees begin to wear, you will be placing less than the desired amount of resin on the deck. The pump operator uses a wand fitted with a static mixing nozzle. The static mixing nozzle has internal elements designed to fold the components of the resin binder system until they are fully and properly mixed. The pump should be properly maintained so that it pumps the correct quantity of each individual component of the resin binder to achieve the proper mix ratio. This is critical for the material to gain the desired strength to handle traffic as intended. Review the manufacturer's recommendations and limitations for storage, temperatures, and cure rates before you begin. This is critical for the longevity of the thin polymer overlay. Curing at any temperature outside of the designed limitations can have consequences that can affect the durability of the system. In this part of the video, the pump operator is laying a bead of resin across the deck evenly and consistently for the width of the deck in a back and forth motion. This will allow the personnel charged with broadcasting the aggregate to stay ahead of the resin binder as the curing process begins. This happens very quickly on a hot day. For this operation, the contractor has elected to use a pneumatic blower to broadcast the aggregate. It is important to cover the wet resin binder to refusal before it begins to cure and thicken in viscosity. The aggregate will fully embed into the resin binder at this time. Waiting too long can cause early loss of aggregate, especially within the wheel path. A loss of friction in the wheel path can become a safety hazard. Notice that the person responsible for broadcasting the aggregate has spike shoes as well. It is important not to disturb the even layer of resin binder with regular work boots or street shoes. This can create an uneven wearing course. An even riding surface is also important for the longevity of the overlay system. It is considered a best practice to broadcast the aggregate in a way that allows it to drop into the resin binder rather than being rolled across the surface. If the aggregate is blown across the wet resin with too much force, it will roll in the resin, potentially creating an uneven wearing course. Another consideration when blowing the aggregate onto the deck is how the excess aggregate may be blowing into live traffic. Often this is not acceptable. There are other methods of broadcasting aggregate available that don't create as much dust and may do a better job at controlling the width of the broadcast as it relates to the lane being installed. As the first course is complete, you can see a straight longitudinal termination. This is important and often done with duct tape or another wide type of industrial tape. Be very careful to remove any tape used with the overlay before the resin begins to fully cure. All drains and joints are typically protected as well. Any protective tape or covering over joints, drains, and terminations needs to be carefully removed before the system cures. As you begin the installation in the next lane, you will want to make sure that the longitudinal joint has a slight overlap. If this is done unevenly, you will have high spots, leaving the center lane cold joint susceptible to unwanted stresses and strains from impact and thermal influences. All terminations and joints are especially vulnerable to early failure and should be treated with care during application. This technical pocket guide is intended to serve as a useful reference during the thin polymer overlay installation process. Much of the guide is organized as a list of items or steps, allowing you to check each item off the list as you observe the installation process. This guide provides some basic direction, and following it minimizes the potential for early failure. Other considerations related to potential problem areas are described within this guide.